Welcome to tonight's video on Unit 6, Section 2. We're going to be talking about parallelograms. And parallelograms are a type of quadrilateral. So a parallelogram is a quadrilateral that has both pairs of opposite sides parallel. So you'll see a quadrilateral that has both pairs of opposite sides that are parallel to each other. So that would make a quadrilateral a parallelogram. So some properties of parallelograms. Theorem 6.3, if a quadrilateral is a parallelogram, its opposite sides are congruent. So opposite sides of a parallelogram are congruent. So anytime you see this little icon here, that means parallelogram. So not only are the opposite sides parallel, but they're also congruent. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So opposite angles of a parallelogram are also congruent. And since their opposite sides are parallel, these angles x and y are consecutive interior angles, which means that the consecutive interior angles are supplementary. So consecutive angles in a parallelogram are supplementary. And since a parallelogram adds up to 360 degrees for the angles, if one angle is 90 degrees, that means all four angles are 90 degrees. So here in parallelogram ABCD, angle B is 32 degrees. So angle B here is 32. CD is 80 inches. BC is 15 inches. So it says find AD, the measure of angle D. Well, remember, opposite sides of a parallelogram are equal. So therefore, AD is 15 inches as well. The measure of angle D, well, if B is 32, remember, opposite angles are equal. So angle D is also 32 degrees. And the measure of angle C, well, remember, consecutive angles are supplementary. So 180 minus 32 is 148. So go ahead and look at this next picture and try to answer the questions on your own. All right, so there is the parallelogram. Any questions on basically to get that? Remember, opposite sides are congruent. So since this is 30, that's 30. And then since this is 20, AD is 20. And then remember, consecutive angles are supplementary. So 180 minus 36 gives you the 144. And that also gives you angle D because opposite angles are congruent. And then C is 36 because opposite angles are congruent there. Some other theorems for a parallelogram. If a quadrilateral is a parallelogram, then its diagonals bisect each other, meaning that this intersection point is the midpoint. So the diagonals bisect each other, meaning that AP is congruent to PC, PB is congruent to PD. So that would be the midpoint. Point of AC and BD. And when that happens, the diagonal separates the parallelogram into two congruent triangles. So notice here, triangle ADB would be congruent to CBD because of the fact, remember, opposite sides are congruent. So notice, and then this is the same in both, so it'd be side, side, side. So some other questions here. If W, X, Y, Z is a parallelogram, find the values of R, S, and T. Well, remember, opposite sides are congruent, so 4R is going to equal to 18. So when you divide by 4, R is equal to 4.5. For S, remember, since S is this angle here, sorry, it's this here, and 8S is there. So remember, in a parallelogram, the diagonals are bisected, so 7S plus 3 is equal to 8S. So you get S is equal to 3. And then for T, remember, since this is parallel, that these two are alternate interior angles, so they're the same. So 2T is equal to 18, so T is equal to 9. All right, so go ahead and try the same thing for 22, and then we'll go over it. All right, so for 22, remember the opposite sides are equal, so that's why 2p is equal to 22. Diagonals bisect each other, so that's why 4x plus 12 is equal to 6x plus 2. And then also, because these sides are parallel, the alternate interior angles are congruent. So that's how you set it up, and then you can just solve to get those values. All right, the next page. What are the coordinates of the intersection of the diagonals? Well, basically, you need to, an MNRP, so if you were to draw, here's M, N is -1, 3. P is 5, 4. And R is 3, 1. So your parallelogram looks something like this. So the diagonals, remember, go across. So you're trying to find the midpoint of either NR or MP. It doesn't matter. You could do either one. So let's say you wanted to find the midpoint of MP. You would do 0 plus 4 divided by 2, and, or sorry, not 0 plus 4, -3 plus 4, because those are the x's. Actually, sorry, it's -3 plus 5 divided by 2, because it's x1, x2, and then it would be 0 plus 4 divided by 2. So that means the midpoint would be 2 over 2, comma 4 over 2, which would be 1, 2. And if you did the same thing for NR, the midpoint, well, -1 plus 3 over 2, and 3 plus 1 over 2, notice it would give you the same thing. So that means the intersection of the diagonals is 1, 2, that point. So go ahead and try the same thing for 24. All right, notice if you draw the picture, the diagonals are from N to L and M to O, so you want to find the midpoint. So if you do the midpoint of each diagonal, notice you get the same coordinate. It's 1/2, comma 1. All right, complete the statement about parallelogram ABCD. AB is congruent to, it would be congruent to CD, because remember, opposite sides are congruent. AD would be congruent to BC. And angle D would be congruent to angle B, because the opposite angles are congruent. All right, an expanded gate is made up of parallelograms that have angles that change to measure as the gate is adjusted. What statements about the congruency can be made about all sides and angles? Well, remember, opposite sides are equal, so you know AB is congruent to CD, and you know that AD is congruent to BC, and then you know opposite angles are equal, so angle A is congruent to angle C, and angle B is congruent to angle D. All right, so that concludes our video on parallelograms. Make sure you know the different properties of parallelograms, and then part 3 will be coming soon. All right.